Greetings and welcome, friends. Mr. Waddy here. We are going over page 380. We were talking about proving a quadrilateral, a parallelogram, yesterweek, yes. And it says, in exercises 3 to 8, state which theorem you can use to show that the quadrilateral is a parallelogram. So notice, in this one, it appears as though those opposite angles are congruent to each other, right? Yep. And I believe, let's see, oh, what do we got? Where is this going? There it goes. Oh, so that must be the parallelogram opposite angles converse? That sounds like a good one. So the parallelogram opposite angles converse. I love it. All right, how about this? Oh, it looks like the opposite sides are congruent. So parallelogram opposite sides converse probably would show that that's a parallelogram. Oh, here it looks as though these diagonals bisect each other. Is there a name for something with the words parallelogram, diagonal, converse? I like it. All right, so we could prove quadrilaterals into parallelograms. All right, this one's a little bit more algebraic and tricky. Question 12, it says, find the values of x and y that make the quadrilateral a parallelogram. So these are angle measures. And if the opposite angles are congruent, then I could prove that it was a parallelogram. So I'm going to find two expressions that only have x's if possible. So I could say these two add up or are equal to each other in measure, or I could say that these two add up to 180. I'm going to do the equal to each other one because 180 is a big number. So 5x minus 12, when that is equal to 4x plus 13, then those opposite angles will be congruent. I don't want that color, I want orange. Here we go. Ay naranjas, mis amigos. Ay naranjas en la cabeza. Right, there we go. So, 5x minus 4x, x minus 12. That was actually a quote from Bumblebee Man and The Simpsons from probably back in the 1990s. When oranges fell on his head when he opened a cabinet. And I get x equals 25. Now, I've still got to figure out the y, because they did also ask for y. So what could I say about this expression? What could I do with 4y plus 7? Yeah. I like it. So, using that and substitution, I could plug this in for x, and then equate those two things because opposite sides, or opposite angles rather, are going to be congruent. So 4y plus 7 is equal to 75 minus 8. What's 75 minus 8? That sounds like 67? Yeah. Ooh, subtract 7 both sides. Wow, guys, the geometry's coming back to me after the long weekend. I remember this. Did you guys miss geometry over the weekend? I missed you guys. Aww. Let's see. And I get y equals 15. All right. So there we go. There's the values of x and y that make the quadrilateral a parallelogram. Happen to be the only combination that will work in this case. All right, how about this? Similar problem, different setup. Find the values of x. Value of x that makes this parallelogram. So the PDC, parallelogram diagonals converse, if these diagonals bisected each other, that would be amazing. And so 5x minus 6 would have to equal 4x plus 2. And you guys know the algebra. We're doing algebra. And add the 6 to both sides. Oh, yeah. Let's see. We got to pick up the pace so we have time for a class quest today. Although we did go over a test, so yeah, we had some loss of time. There we go. So x equals 8 would be the value that would make those diagonals bisect each other, and then by the parallelogram diagonals converse, the quadrilateral would parallelogram itself. So there we go. given graph the quadrilateral with the points and the such. I forgot to give you guys some coordinate plane on this one, so sorry about that. My bad. So I'm going to have this be my origin. The reason I'm doing that is because I happen to notice that all of these are positive for their coordinates, so quadrant 1 sounds like a great place to be. 0, 1 right here would be A. B is 4, 4, over 4, up 4. There's B. C is at 12, 4. So 1, 2, 4, 6, 8, 10, 12, and then up 4. Okay, there's C. And D is at 8, 1, so over 4, over another 4, then up 1. There is D. Now, as far as proving that these 4 points that make a quadrilateral are parallelogramness is maximized, there's like a bunch of different ways I could do it. I could show that opposite sides are congruent. That would be a 4-distance formula problem. It's a lot of work, though, doing 4-distance formulas. I could show that opposite sides are parallel using the definition of a parallelogram. But that would be like 4 slope formulas. I could show that opposite sides are parallel and congruent for one of the pairs using 2 slope formulas and 2 distance formulas. The easiest way is using the diagonals bisect each other. You guys remember that one? Yeah? So let's imagine these diagonals. If they bisect each other, what type of point would that be with respect to the opposite corners? This would be if I could have the midpoint for both BD and AC be the same point, then I would know that my diagonals bisect each other. So that's the easiest one, and that only requires me to use a formula twice, and the midpoint formula is a pretty easy formula to use. It's the average of the x's and the average of the y's. Man, I've still got to do a proof after this. This is going to take forever. Oh, man. All right, so midpoint of ACMP would be 0 plus 12 over 2 and 1 plus 4 over 2. So that's going to be the point 6 comma 5 divided by 2 is 2.5. So 6 over 6 up 2.5. That looks like that's graphically correct. And the midpoint of BDMP is going to be 4 plus 8 divided by 2. Right, so this is the easiest way to do it. And the y-coordinate would be 4 plus 5 divided by 2. This is already looking 4 plus 1, sorry, divided by 2. This is looking good. Question, Evan? Comment? Well, it's 4 uses of formulas. So, I mean, it works just as well. It's just a matter of, like, here I'm doing, like, 2 uses of the formula. I don't know. You could argue that slope formula is pretty easy. I don't know. A bunch of ways work. 4 plus 8 is 12. Divided by 2 is 6. 4 plus 1 is 5. Divided by 2 is 2.5. Because those are the same, the diagonals bisect each other, and the parallelogram diagonals converse says that this is a parallelogram. Right? Parallelogram. Hooray! Okay, here we go. Let's talk proof. Proof. All right. So the first thing I'm going to do, it looks like I'm proving the opposite side congruent and parallel theorem thing. Yeah. So let's start with the gimmies. Rip. It looks like they drew one of the diagonals, and let's see how that's going to help us in proving this is a parallelogram. All right, so can I prove these 2 angles are congruent? I actually can't. No. It's the other ones. I can't prove these ones because I don't know that those are parallel to each other. Yeah, so let's work with those 2. So that means the measure... Actually, no, I don't need measure. I'm just going to work with the angles. RQS is congruent to angle PSQ. Reason? Oh man, remember that back when like that was one of the first things we learned? Wow, with proofs, I love it. I love it. Let's see, what else can I show and or prove? All right. Okay, so it looks I feel like we're moving towards a CP-CTC. Yeah, so reflexive. Do I have enough to prove these two little triangles are congruent to each other? So I'll call that triangle PSQ is congruent to triangle RQS. And why are those two congruent to each other? Side, angle, side, because I've got two sides, and they're included, they're in between angle, congruent. Now, what would be the next most helpful thing to say? There's a lot more that I could say, but what would help me most? Josh? We could. Oh, use like one of the opposite side ones? Yeah, that would have worked. That would have worked. I was gonna try to direct this through the definition, but I think at this point we would be allowed to assume we already knew that theorem when we were proving this one. So yeah, so you could say that. I'm gonna just go by the definition route, but you would be 100% correct doing that one. So I'm gonna say this angle and this angle are congruent. So that's angle PQS. And so many like proofs for dyslexics would be terrible. I apologize if you struggle with that. Like these are all just like swapped letters, but they're all important in the order that they're written. Yikes. So why are these two angles congruent? Because I already know the triangles are congruent. CP, C, DC. Corresponding parts of congruent triangles are congruent. And since those are congruent, I can now show that these are parallel. Right, QP is parallel to RS. Why is that? Oh, with the converse. That's right, because I knew the angles were congruent. Therefore, the converse allows me to show the sides parallel. And then I could say PQRS is a parallelo. Right? By def of parallelo. I like it. All right, very good. Thanks for watching, internet friends. Ay, 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 mis dedos de los pies.